Well, there's two questions. He was talking about having a deep cycle battery, 2 golf carts put in series to start an engine. I'm saying you want a starter battery. Ideally, it's better to have a starter battery unless you have a massive deep cycle bank. Let's say you said to me, Jeff, I'm not running a house and engine battery setup, but I'm running 4 golf carts and 4 golf carts, right? On port 1 and port 2, right? Yeah. But let's say, but now you're only using, but I'm not using starter engine. I'm using house 1, battery 1, battery 2. For me, they're not engine or house. They're battery 1, battery 2. Yeah, you could do it because now 4 of them is comparable to a Group 31 battery, right? But why would you do that, right? Most people now, the model is dedicated battery for house, dedicated battery for engine, and people are not doing what used to be the case in the 70s and 80s and 90s where they would divide port and starboard battery banks. That is being phased out. People are getting dedicated batteries for dedicated purposes, and they're not they're having a checking account and a savings account, not 2 checking accounts. Right? They're saying, this account, my savings account, I only touch to run my engine. That's all. It's always there, like it's dependable like our cars. And that's the model where people are going to, is now the idea of when I push the start button, I want it to go. Right? And so that's why they would do divide and conquer. House, deep cycle, starter, cranking. Okay? Does that give you a brief summary? Your
battery selector switch has the capability of choosing for you, right? You don't have to have it always on 1 or bank 2.
Yeah, those source selector switches are a legacy item from an old way of thinking where people, again, used to blame electrical for the problems on a boat and would blame the batteries. And the designers hadn't come to the grips of the fact that the person using the boat was the one that was going to cause the failure electrically on that boat. So the idea was batteries are unreliable. We'll involve the owner in making the decisions of managing the boat because the owner knows best. And then the model was, we'll start off, no batteries are connected. The owner is going to start on 1. The engine is going to start. He will always remember to not turn it to off ever, because if he does, he'll blow off the alternator, but he'll never forget that because he's an amazing owner. And then he's going to go from 1 and he's going to go to both, and while the engine is running, both batteries are going to be charged. And then when he's getting in his anchorage, he'll never find a reason or not have the time to go down below and turn the engine switch back to 2, which is house. And then run the night over and then repeat, start on 1, both, 2. The reality with that model is it expects an owner to never ever forget to turn the switch back to 2 or 1 when the engine is not running, and to never turn the switch to off accidentally when the engine is running. And also to assume that the battery switch is not old and it always is going to make a make before break contact, because it always does. And over time, at one point, even if it opens it just for a millisecond, the alternator is going to blow. But that's not going to happen when the battery is new, switch is new. It's going to happen maybe 20 years later. So all those 3 assumptions are the reason people have come to grips with the fact that, and that's why Jeanneau's and Benetton's don't give those options anymore. There is no parallel switch on any charter boat. Because the reality is, people always think that more is better. And they're like, well, it always works on both. More the merrier, right? So why don't we put it always on both? I start on my engine on both, I run my engine on both, but then what happens is when you drain the battery too much or your batteries get old, when you go to start, you have no more backup. Where's your backup? You have no more backup. And so that's why now the new switches are off on combine. And combine is emergency, is in yellow. Source selectors are still there and we put them on, but we use them not the way that you probably have them on older boats. And again, it's more for a very savvy owner, an owner that really understands. There's more pitfalls in an off 1-2 both switch than there are benefits.
So you need an isolator. It's a good idea to have an isolator.
Yeah, or what you do is you keep them completely separate, and you have what he might be talking about is what's called an automatic combiner relay or a voltage sense relay, which is a device. It's effectively a digital solenoid, and that digital solenoid only puts the batteries in parallel whenever there's a charging voltage, and disconnects the batteries when there's not a charging voltage. Okay, so battery charging. This is basically the different charge voltages that you can see. These numbers vary depending on manufacturer to manufacturer. It's not like this is a chart for a battery manufacturer. We commonly see more than 14.6, 14.4. And then 14.6 is more for AGM, but they vary from manufacturer to manufacturer. And then you'll see these are the different float voltages. You'll notice gel here is 14.1. An internal regulator on an alternator outputs at 14.4. 0.3 volts is a massive deal, okay? It's a little bit like your actuator in your car for your gas. Your actuator, your pedal in your car, does not move this much to go from 0 kilometers an hour to 100 miles an hour. It moves this much. That's all it is. That's it. Within 1 inch, you're going no speed to full speed. A float voltage, which is this, is 13.4. Let's say call it 13.6, and I think it's a little lower depending on the batteries. I'd say about 13.5 depending. But look between that value and this value here, 13.4 to 14.6, you've got about 1.2 volts. 1.2. So if your range is from dead slow to full throttle, because bulk, at that speed, you're going max current. You're throwing everything at the battery to recharge it as humanly fast as possible until you get to that point. If your range is 1.2, think about how big 0.3 is. 0.3 on 1.2 is massive. It's not like, oh, I'm only eating about 25% more calories than I need. I don't think it's going to affect my weight. Or, oh, conversely, I'm only eating 2/3 of what I need. I don't think I'm going to lose any weight. I think I'm going to be quite fine. I don't really need all the calories. I'll just eat 2/3 of it, and I bet that I'm going to stay healthy forever. That variance is extremely huge. So don't kid yourself. When you have, and I was on a boat the other day, the owner changed his batteries twice on his own, the art of do-it-yourself, changed twice to AGM, twice lasted 2 years, and asked himself the third time, maybe it's not that I'm unfortunate. Came on board. The owner had AGM batteries charged to a flooded profile, chronically undercharging the batteries, and his batteries were changed twice in 4 years. We just changed them now to AGM. He had a charger that was AGM compatible. He never knew there was a switch on the AGM charger to make it AGM. And so the batteries, AGM batteries are group 31s, about $350, $400. So he lost $2,400 for that mistake. On top of my time to go on the boat and then find out and ask questions. I'm like, oh, what are you doing? And where's your charger? And where is it? Oh, it's under here. It's hard to get. And then I look, have you changed the profile? I think so. And then you look, you're like, no, you haven't. Oh, I had to do that? Yeah, you did. So this really matters. Really, really matters. So you can't go and change your batteries from one profile to another and not worry about the charging. Okay, really important. So if you have flooded on your boat, everything's made for flooded. If your boat is less than 15 years or the chargers are about maybe even 15 to 20 years, there's hope that you're going to have an AGM or gel profile setting. If it's more than 20 years, it's basically either flooded or gel. And if it's 30 years or more, it's simply just flooded. These are where you have different voltages, right? These voltage values, I want to remember people, are really only accurate when the battery has neither been charged nor discharged for a 24-hour period. Think how often that's going to happen with a deep cycle battery versus a starter battery. Starter battery all the time. You run your engine, you stop running it, you leave your battery, there should be no loads on it. 24 hours later, you check the voltage is going to be an accurate representation of capacity because you've neither charged nor discharged the battery in 24 hours. It's been sitting there untouched for 24 hours. This voltage is a perfect representation of battery capacity. Now, try to think about doing that on your house battery. How often is your house battery used while you're at anchor? It's constantly. It's like saying, how often do you drive your car while you're driving your car in the city? Well, you're always driving. It never stops. Your car stops at the red light, starts again, accelerates, water pump comes on, inverter comes on, light comes off. It's constantly going like this. And the inverter might come on, so now you're on a highway, right? Full speed. Now you get off the highway. Suddenly you're on the highway, but you go second narrows, you stop. You're going through the tunnel, speed up, speed down. So your voltage is going to constantly be changing all the time. And I have owners that come to me and they're in panic. They're like, oh my God, Jeff, my batteries, I'm at 11.5 volts. This is crazy. I've just started my vacation. What's going to happen? They're dead. I'm like, okay. What are you doing? Well, we're cooking. Okay, cooking. Your microwave is going? Yeah, microwave is going. What else is it? Well, we're watching TV. Oh, you're watching TV? Okay, all right. What else? Well, the lights are on. Okay, all right. Can we go to your battery monitor and see how many amps you're drawing? Go to the battery monitor casually, and this is unrelated to volts, by the way. You can see how this unrelation is always happening. Oh, we're drawing about 172 amps. I'm like, you're going 400 miles an hour on the highway, and you're wondering why you're burning fuel. Like your volts at 11.5, massive battery bank to hold that voltage, obviously. Like 11.5 is a miracle, but it's huge battery bank, like maybe 1,600 amp hours. I'm like, no, it's quite fine. Like your 11.5 volts at 170 amps is quite good. It's quite good. There's no need to panic. What you need to ask yourself is, how long are we going to be burning at 172? That's really what you need to ask yourself, because we need to minimize that amperage. It's like revving your engine at 5,500 RPM on a gasoline-powered boat and really worrying about fuel burn. It's like, yes, do you need to go that fast? Right now, all at the same time. And so those voltages are all make sense only if the battery's at rest for 24 hours, right? And the other way to think about it is a little bit like breathing. Breathing and voltage is actually very similar in the sense that one's resting heart rate or breathing is a function of what you're doing in terms of an activity level. If you're doing the grouse grind in 45 minutes and you're huffing and puffing, you're quite healthy. But if you just got off the couch and you're walking to get a glass of water that's 10 meters away and you're breathing hard, that's another problem. So voltage is always used in conjunction with your recent activity level, like now, like are you running, sprinting right now, and what have you been doing for the last 24 hours? And the only way to do that, because it always varies on a deep cycle battery, right? You're not like on a highway going always 90 kilometers an hour for 7 hours nonstop. In the city, you're driving, your speed varies all the time. So does your loads on a boat. And so the only way of accurately knowing the depth of discharge is a battery monitor. A battery monitor. We sell about 200 of those a year. And I don't mean sell, because I don't really sell anything. I install, well, not myself, but we put 200 battery monitors a year on a boat. It's the best thing you can ever do. If you're going offshore, you have to have one. It's not even an option. It's another black and white. You have to. Battery monitors tell you not only the level of batteries on your boat, like a fuel gauge, but they also tell you the rate at which you're discharging your batteries. It's like a speedometer, right? Remember what I was telling the owner? He was freaking out. You need to freak out. If you're on a boat and you don't need to go at 40 knots, you don't go at 40 knots, not because you don't want to get there fast, because you care about money, and money is a limited thing, and you don't want to burn fuel you don't need to. On a boat, batteries are like money. It's a rare thing. You want to conserve your power, and the way to conserve your power is to reduce your consumption. And the best way to reduce your consumption is to be aware of what you're using. And the only way to be aware of what you're using is having a battery monitor that captures all the current going in and out of the battery, not just what's happening at the panel. Because over time, a lot of loads are not just at the panel anymore. Inverters bypass panels. Tons of things bypass panels. And so the amp gauge on your panel is only seeing loads, not at the battery, but loads that are connected at the panel. And that's why you want a battery monitor that tells you all the loads that are going in and out of your battery bank. These are not like, this is not $5 grand. This is like 200 and 250. There's not a reason why, if you're using your boat for cruising and you're actually leaving the dock, that you shouldn't consider a battery monitor.
Will a smart charger show you that information?
No, absolutely not. Smart charger only shows you the output on a voltage of what it sees at the charger. It doesn't even tell you what the volts of the batteries are. Smart chargers only tell you the voltage at the charger. They don't know what's happening at the battery. They assume that the voltage drop on the line is negligible, so the volts at the battery are the same as the volts at the charger, which is not true, and hence why it's a battery charger voltage is always higher than what the battery sees.
Battery monitor is relatively easy to install.
Nowadays, yeah, 3 hours, I'd say. The big issue is if you have, you know, those boats that have all the negatives on the battery, you need to take all those negatives off and you need to put them on a distribution post, and then you have to choke point, which is called a shunt, that captures all the current going in and out. And they do that on the negative, right? It's like a circuit. You gotta capture everything. So nothing can bypass the battery monitor. So no, they're not that complicated. It's not like a day, 3 hours, 4 hours, depending on the, it could be as low as 2. If your boat was perfect and everything else was great, it'd probably be 2 hours. But the reality is most boats aren't, so then you have to fix things to make it work. Question?
So I have that Sandflex battery
Yeah.
monitor, love it fixed, but it would also help if we were, a big straw is always ringing up using the windlass.
Yeah,
Would it also help to figure out what the optimum revs that we would need to run the engine at? Would that help?
absolutely. You're gonna actually
Is
see,
that optimum, like, okay, I need to run,
yeah. You're gonna see that, well, you'll see 2 ways. You'll see both the voltage directly. The voltage is gonna give you an indication because it's happening in real time. And you'll also, if you move it over, you'll see the amps. You'll see the amps coming out of the alternator. Now, you don't see the amps out of the alternator because remember, the battery monitor gives you an aggregate view. It gives you a sum of all the things that are happening at your battery. So it's the net effect of the loads and the charge. The difference between the two is what you see. So you'll never see, for example, what your alternator is unless you had no loads, right? The way that now on really fancy boats where I get to do what I want and I dream and I do everything, we end up putting stuff everywhere. But honestly, that is 1 out of 300, 400 boats. Like people that have monitors on individual charging and no alternator output, solar panel output, this, and they have those people are geeks, they're like me, and they have lots of money, right? They have to because it's expensive, and it's really not required. I mean, sure, it's nice to have, but it's really not required. Most of us, like 99.9%, will have 1 battery monitor on the deep cycle battery. And seriously, if you want to know what your loads are doing individually, get a clamp-on meter and clamp your alternator output and measure what the alternator output is. That's $70. Putting a battery monitor and current shunts everywhere, you'll see that on super high-end boats. But you're not going to see that. It's not required for, it's just, we don't ever do it, really. It's very rare. Does that answer the question? Okay. So this is a question of battery bank sizing, right? Like there's a 50% you don't use, but then there's a 50% you think you're going to use. But the reality is that that 50% is really, really hard to get. Why? Because that's absorption charging, right? And in absorption, you're charging at a marginal tax rate, a very high. This is no tax. Everything you can throw at the alternator or the battery will take, pretty much. 25% for flooded, 40% for AGM. With the battery banks that we have nowadays, the limiting factor is simply that you have much bigger batteries than we have charge rates. So the reality is that at one point, you're charging at full capacity, you're throwing everything it can on the battery, but once it gets to about 85% of capacity, which is 14.4 volts for a flooded lead acid battery or 14.6 with an AGM, once it reaches that voltage, then the current starts to be limited because it can't go higher than that. So bulk is like an on-ramp on a highway. You press on the accelerator, you try to go as fast as humanly possible to the top speed, which would be 14.6 or 14.4. Once you get there, then you have to pull back. You're not accelerating anymore. And now you're pulling back to keep the voltage steady. And as the voltage stays there over time, the current starts diminishing. That diminishing of current makes it very inefficient to recharge your batteries in this, right? It takes forever. You'll take the same amount of time to charge this as you'll do this. So owners are finding themselves doing more bulk charging. This won't matter on solar because you have time. But if you're running your engine or you're running a genset, you're going to stay in bulk charging. And that's why when you size a battery bank, you end up sizing a battery bank for 1/3 for a flooded lead acid battery. Right? That's where the 35% comes in. With Firefly, you can go all the way down to 20. So the range is from 20% all the way to 85%. So you have 65% of the battery that's usable. Now, that sounds great, like my Bentley Coupe, right? It sounds awesome. It looks great. There is one caveat. It's 4 times the price of a flooded lead acid battery. Okay? So this is, when you're figuring out what you need in terms of battery bank sizing, you need to calculate what your estimated usage is going to be 24 hours. And I told you the range is between 50 and 200, but a battery monitor would tell you that. This is add up all the amps, but that's if you don't have a battery monitor, and that estimate is always wildly inaccurate. I have people coming and telling me they have like a 38-foot sailboat, and they're like, Jeff, I'm planning on, while I'm underway, I'm going to be using 1,850 amp hours a day, and when I'm at anchor, I'm going to be using 725. How big should my battery bank be? And I'm like, can you tow a barge with you while you're going to be underway? I'm like, no, but look at my spreadsheet. I'm like, yeah, but junk in, junk out. I don't question your math. Arithmetic is good, but you're not going to be using the water pump as much as you estimated. You're not going to be, nobody's using 700 amp hours at anchor on a 38-foot sailboat that has no AC loads practically. I know the math tells you that, but you overestimated all these things. And so what end up people is doing is when they put in this stuff in Excel spreadsheets, the numbers can be variables, like multiples of what reality is. And therefore, the only real way to understand how much money you spend in life is look at history. Don't predict based off, you know what I mean? Like there's predictions in life, and then there's reality. So a battery monitor will tell you over time how much you use. Figure the difference between, especially if you're going to go offshore, the difference between underway, which is much higher than at anchor, right? And then figure out and see what are the different things, like you're going to be on autopilot. That's a big one, right? Really big one. And the other question too, and we'll take a break after this, is because now that we're figuring out what the different deposits, like how often are you going to be able to recharge your batteries, right? Because it's one thing to have a battery bank, but do you size it for just a day? So every day you need to recharge? Or do you have a battery bank that's going to let you be on the hook for 3 days, and then over time you need to recharge maybe once every 3 days? So it depends. So how often will you recharge? Are you going to recharge with wind? Are you going to recharge with solar every day? Is it expecting to be, sunny? I have some owners that are going up to Alaska. I'm like, well, solar is going to work, but don't expect it to work as good as it would, let's say, in Desolation Sound when it's pretty much sunny all summer long for the most part, right? Are you going to be tow gen? Do you have a generator? How long are you going to run your generator? You're going to run it an hour in the morning, an hour at night? Are you going to run it only once a week? So all these variables are going to really influence how you size your battery bank. Because at the very least, you want 1 day's use, but you might need 3 days use out of your battery bank, right? To be able to kind of tolerate those discharges. And so be conservative within reason. Another way to look at that is talk to other boaters that have similar boats, that have similar type of cruising habits that you would. Same type of gadgets, same type of things. Are they cooking with what are they cooking with? Where are they running a TV? Do they have satellite TV? Do they have, you look at all those loads and you go, yeah, I'm probably going to be, they know their number. I think I'm kind of in the, just to at least quantify or validate that your assumptions are right. So that you're not sizing your battery bank for 3 times more than you do or you need because you just thought about it through an Excel spreadsheet that you got at West Marine and you're just punching numbers in. Because it's honestly, it's incredibly disappointing how those numbers can be really over-exaggerated. So we'll take a break and then we'll look at different charging on the way back. What are you doing? Powering through here, not being too tired? All right, we lost a few troopers. We're still making progress here. Nobody said boating was going to be easy though, right? So,
Still fun.
yeah. So we talked about batteries and we talked about sizing, and it's actually pretty complicated. I'll do a 2-hour presentation on battery sizing, which again sounds like a lot of work, but you've got to really figure out what you're going to do. But anyways, we can't do everything. This course could last honestly 20 days. Every one of these topics could be an afternoon, a morning, and 20 days wouldn't be even enough. You can make a lifelong learning, and it never ends, and there's always more to learn here. So we're just skimming the topics and just giving you kind of a brief overview of what are things you've got to maybe dive in more and learn more about. So you have batteries, but now batteries it's a wallet. I mean, you can store cash, but you got to make cash, right? So it's really nice to be able to store money, store power. And yes, it's essential, especially when you leave the dock. But the reality is that you're only going to be at the dock for especially if you're going offshore, you're actually cruising, you're not at the dock every night. We're not like day sailors out of Marina del Rey. We go out, bomb around on California, look at a flat coastline, tack, come back in the evening and have cocktails. We're leaving the docks and we're going to anchorages, which is a real rarity anywhere else when you think about it. Most other places leave the dock to come back to a dock. They're RVers, right? The RV only goes out while it's but it eventually goes back to some place where they can plug in. Very few people do dry camping, as they call it in that industry. And so the question as a boat owner is, how do you recharge the batteries? So first thing, when you're connected to shore power, the easy thing is to use a battery charger, and battery chargers are effectively converters. That's what they are, right? It's a device that converts AC power to DC. They used to be called converters on all the old panels. They stopped using that word because that's a marketing word. I mean, this doesn't mean anything other than what the engineers or the designers intended it to mean. And that word died after all those batteries over time were getting chronically overcharged. And so they stopped using that word, and they came up with a new product called a smart battery charger, not a converter, but they called it a smart battery charger. And smart battery chargers have 3-stage charging, which is bulk, absorption, float. Bulk is ramp up, absorption is steady, float is back down to another steady state forever. Absorption is a maximum amount of time, generally as a function of battery capacity. Float can be in perpetuity. That's the simple of it. There's variations on that, but pretty much that gives you a good reputation, understanding of the choices that you have. There's different types of battery chargers. There's like 20 amp, 15 amp, 10 amp, 100 amp. I mean, there's a huge selection. You'll basically, common sizes here are 30 to 60. You can buy them in 100. We definitely install a lot that are 100 but that's a little bit rare. They generally come on inverter chargers, large chargers. Like a 2,000 watt inverter is going to have a 100 amp charger, or a 3,000 watt inverter is going to have a 150 amp charger. And we'll talk about inverter chargers a little bit later. Very important, they charge batteries in 3 stages, bulk, absorption, float. They must be set for the correct battery type. Don't do that if you don't value your money. But if you value money, you want to make sure that you actually set it. And don't assume that you have a charger that it can charge AGM. You need to make sure that it does. And gel and AGM are not the same thing. Even though someone at the store that sold you the battery is going to call an AGM battery a gel battery, or a buddy's going to say, oh yeah, they're gels, you're fine. They're not. All right, next thing is, so that's one way, right? Converting AC to DC. Yeah, go ahead.
Can we go back one? So just, you may get to it. So it says you're charging 3 stages. So on my Xantrax charger, it gives me a choice to set at.
You're talking about a True Charge 1 yellow charger.
Yeah. Well, no, mine's white, but.
Why? Oh, it's even older. Stat power.
Yeah.
Yeah. Okay. Do not. There is only one right answer there.
Okay. And it is
3-stage.
3 stages.
Absolutely. When they came out with those chargers, there was probably people that were old school. First of all, boaters in general don't like change. That's a rule. And so whenever they came out with products, they probably wanted to make it an easier transition. And so they gave a converter option on a modern charger. Modern chargers don't give that option anymore. There's no such thing. It's impossible. You can't. Only very old chargers do that. And because you're on the cups. It was on the transition between a converter and a smart charger.
Right.
And you'd have 3 charger profiles. And one of them would say fixed, 13.5,
Right.
2-stage,
Yeah.
or 3-stage.
Correct.
And there is only one right answer. It's 3-stage.
Okay.
The other 2 are actually pretend choices and for people to just feel good, but you should never use those choices. We've come to the realization that a battery charger on 3-phase can be left on 3-phase permanently forever. You can have it for 10 years.
Doesn't matter what type of battery.
Nope. Well, flooded lead acid battery.
Yeah, well,
And as long as it's the right charge profile and the right temperature profile, but yes.
and temperature, just to go back on that.
Yeah.
So let's say like right now, because it gives me 3, it says cold,
Cold.
warm, hot.
So I would do,
Right in that.
I would do cold. Well, the problem is if you do cold and it's not cold, you're going to overcharge. If you do warm and it's cold, you're going to undercharge. So you got to choose what you want. I would say, again, based on the fact that you're probably going to forget to do that next time it gets cold or warm, I would go with warm and leave it in warm as a compromise.
Right.
Because you can promise to do something and set it for cold in the winter, remember to turn it to hot in the summer,
Right.
and not remember and go, oh, crap, and then lose your batteries. So you don't want to, it's in life, you just don't want to walk too fine of a line. It's perfect to walk a fine line, but the problem is, can you hold that fine line forever? And if you forget, then the benefits of charging perfectly are going to be outdone because you're overcharging. Newer chargers have temperature sensors. Literally, temperature sensors, we talked about it. It's a known resistance that varies depending on temperature. And they're sending on a telephone wire, measuring for a resistance, and they have a table inside, and they're saying, if it's this resistance, then the temperature of the battery must be this, and therefore change the voltage for this value. Because when you talk about battery voltages, all those values that we talk about are nominal voltages at 77 degrees Fahrenheit. So all those values like 13.3, 14.4, 12.6, 12.2, all those numbers only mean something at 77 degrees Fahrenheit. Okay? That's also, it sounds complicated, right? It is. That's the reality. And if you can buy a battery charger that has a temperature compensated profile with a temperature sensor, you need to do that. But where are you going to put it? I have people we saw, one, they had it left right beside the battery charger, right? I have other people, they put it on the warmest battery or the coldest battery. So if you've got battery banks and one of them is going to be the warmest, you never want a temperature sensor to measure the coldest battery. You want it to measure the warmest battery. So the one that's closer to maybe the engine, the one that's closer to whatever, and you use an infrared gun over time to figure out what that is, because you'll have not one battery, you'll have multiple batteries, and it's really important to make sure that you capture the warmest battery, especially for thermal runaway. Another way to recharge your batteries is what's called an alternator. Alternators convert the turn of the engine, and they're going to either do it through V-belts or serpentine belts. And you can see in this picture, it's right over here, it's red. Single V-belt. Single V-belt is about maximum of 90 amps you can get. You can go higher on dual V-belts or even higher on serpentine. They're going to make, you can buy alternators for different voltages, so they can make double that. You can buy a 24-volt alternator, but for the most part, they're 12-volt alternator. The output actually, it's not so much where it starts, it's how high it can go. A nominal alternator that you have in your car outputs at 14.4 volts. That's a standard alternator, and that's what it outputs. It's meant to recharge the batteries. The output varies around 30 to 150. They go higher. I've seen 300 amp alternators on really big engines. But for the most part, on a sailboat engine, they're going to be around, stock alternators around 55 amps. And they can go higher. And like I said, on a single V-belt, you can put 90 amps. And then you can go 165 on a serpentine. We've done like bigger alternate, small case, but good alternators, to about 165. This is really essential. alternators, and we'll talk about this before, but I'm going to dive into it. When you see your alternator and it says 55 amp alternator, I just want to break it to you. You will never see 55 amp of that alternator in your life. Okay? So that is called marketing, and it's an apples to apples comparison. But you will never see 55 amps. That 55 amps is this theoretical maximum output of that alternator. Just one second. When the engine is going at maximum RPM, and think how often you do that. Other thing is cold rated, so meaning the alternator has not been running at all, and it's going to get hot or operating temperature within half an hour. It assumes that the battery voltage is the same at the back of the alternator like on the battery, and it isn't, because the output at the alternator is not the output at the battery. And the alternator also has an internal regulator, and the internal regulator decreases output by about 2/3. So honestly, a 55 amp alternator at wide open throttle, not wide open, but cruising RPM, is probably going to give you about 25 to 30 amps. That's what you're going to get from it, minus your loads. So think about what you're netting, right? Because it really doesn't matter how much money you earn in life. If you're worried about retirement, it's how much you save, right? Same thing with your batteries. How much you earn is really irrelevant. It's how much you're saving. And that's why you need to get yourself higher up in the amperage. Because you're going to be, when you're running your boat, you might be running 10 amps, 15 amps of loads. So if you're only outputting 30 and you're burning 15, then you're only netting 15 for savings. 15 in a battery bank daily amp hour, maybe 100. 15 and 100, that's 6 hours. 6 hours to recharge. Now, how often are you going to be running that engine for 6 hours a day at running RPM, which is like 22, 23, 2400 RPM? You're not going to do that. It's crazy. So those people get in deficits and deficits and deficits and deficits and deficits. That's why running an engine with a stock alternator is extremely disappointing, and why there are solutions that we're going to talk about a little bit later, how to upset it. Did that answer your question? Or?
Kind of. You got into the rating. What's the hot rating?
Well, the hot rating is the cold rating minus 15%.
Okay.
So the number that you see, 55 amp, is the cold rating. That means the alternator will output 55 amps for the first 30 minutes. The moment it starts operating at full throttle, right there. Over a period of 30 minutes, it will be derated by 15%. That's the hot rating. And that's what's realistic, because who cares? I mean, how often do you run? The first 30 minutes is gone. You might run your engine for 3 hours. Only the first 30 minutes and the first moment of the first 30 minutes gave you the cold rating. Okay? Any questions? Things to think about. You know, alternators fail. They get really hot. They're not really built for boat engine spaces. They're built for better ventilation. Especially on a sailboat, the heat inside an engine room is insane on a sailboat. It's crazy. Most people don't run blowers because there's no diesel, there's no gas. So the temperature gets really hot. And these alternators end up dying because of bearings, brushes, and diodes actually overheating. So what they're saying is if you're going to go offshore, you probably want to carry a spare. I mean, and remember, if you're a sailboater and you don't have a lot of alternative ways of recharging your batteries, in the past, this was, for many of us, the only way to recharge our batteries. Nowadays, there's different ways. You know, people are doing solar, and they're doing tow gens and wind gens, and right, they have maybe generators, and so there's different ways. But this is a pretty primary way of recharging. So make sure that you have a spare and you know how to change it. This is where I'm coming in, and I'm going into external regulators. External regulators are a way for you to recharge your batteries with a smart charger profile. So it goes through bulk absorption float, and you can set it to AGM, you can set it gel, you can set it to everything. It has temperature sensors, so if the alternator overheats, it senses it. It has temperature sensors for the battery, so it's temperature compensated, and measures voltage not at the alternator post, but at the battery, which is a massive deal. Most people, again, remember the recurring theme? I should have like top 10 themes. People don't read manuals. That's one. Other one is people think they're smarter than the manuals, right? Now, people that have never installed that product before, I mean, it's amazing how humans have, the audacity is incredible. You've never installed the product. Somebody wrote a manual to install it. They manufactured it. You read it. And a lot of people are saying, well, that's just dumb. Because they're not having a conversation. It's a piece of paper. So then what they do is they decide to take shortcuts because humans love shortcuts. And so what they do is instead of bringing the voltage sense wire for the alternator to the battery, which is what the manufacturer of the regulator tells you to do, they're like, well, why would I bring a cable all the way to the battery when the battery is connected via the alternator wire to the back of the post on the alternator? Isn't it much easier to just install the voltage sense wire at the back of the alternator? And that would save me a lot of time because my regulator is right beside my alternator. And I've just saved myself an hour or two. And then you tell yourself, pat on the back, probably. I'm so smart. And remember, this is a conversation with yourself, by the way. So there's not a lot of feedback on that conversation. And that conversation is not going out of the boat. It's just yourself. So you're like, wow, I did really good. Those guys at Balmar and Xantrax or Ample Power, they really don't know what they're talking about. Maybe I should start a business. I should do that. I got it. And they are foregoing the best part of an external regulator is the fact that it measures voltage at the battery. What that means is actually, it doesn't even care what the alternator is doing. It's saying, I want to see 14.4 at the battery. So the alternator is going to be outputting maybe 15.2. It's going to offset the voltage drop on the line between the alternator and the battery. It's like saying, I don't like taxes. Oh, don't worry about taxes, just make more money. 50% tax rate, you make 100, you have 50. Actually, it'd be really nice if I could just make 100. Oh, well, just make 200. At a flick of a switch, the alternator output offsets the voltage drop. It actually outputs 14.8, 15.2 to offset the 0.4 or 0.6 volts that you're going to lose on the line. It's a miracle. I mean, it is literally one of the biggest advantages of an external regulator is to have voltage sensing at the battery. And most external regulators, where are they wired to? At the alternator. Why? Because it's the easiest thing to do. They don't listen to the instructions, they didn't read the instructions, and because they're smarter, and because the conversation was with just themselves, they absolutely eliminated one of the most important benefits of an external regulator. So if you have a sailboat and you want your alternators to recharge faster, an external regulator is the #1 way to go. I think anyone that goes offshore, anyone that has a sailboat that likes to sail and doesn't like to run their engine all the time or wants to reduce their engine runtime to recharge their batteries should have an external regulator. They're about $500. Takes time to put one in though, by the way, if you do it right. If you don't do it right, it's so much easier. But like anything else. It's amazing. Absolutely amazing. You're going to get probably, if you had you're going to gain probably 1/3 of an output from your alternator. So that's pretty significant, by the way. So I always tell people that want to put a larger alternator, I say first, do an external regulator, see what you get out of your existing alternator, and if it's not enough, it's easy to change the alternator. That takes no time. And then get a bigger alternator.
Does it make any sense having an alternator for starter and an alternator for house?
Some people would do that. Redundancy is nice, of course. Having 2 alternators, but very few boats have that option. Making that a dedicated starter and dedicated 2 alternators on one engine starts getting pretty creative. And the fabrication involved in that is not straightforward. It's not like, oh, by the way, I want a second alternator. Oh, just plug it here. Like you need to start doing a lot of fabrication for that. I think now that there are devices called battery isolators that are FET as opposed to diode combiners, there's really no reason to have 2 alternators. Of course, more is better. But I would say take that money and look at alternative charging like solar or wind. Assuming that you have a finite pool of money. No finite pool of money, then yes. But I would say I would do, for sure I would do 1 alternator, external regulator, then I would have a FET combiner, then I would do probably solar, then I would do wind. And then maybe after that, maybe togen, and then after that, maybe a second alternator. I would look at other ways of charging other than adding another alternator. Especially now considering that wind turbines and solar can give so much output. So this is inverters. Inverters convert, we talked about it, from 12 to 120. They basically are creature comforts. You know, most of us, maybe, okay, some people have CPAP machines, you know, for breathing at night. So maybe, okay, sure, that's not a creature comfort, it's a necessity. But a blender, an espresso machine, a TV, a microwave, all those things are nice to have, I think. Yes?
Does an alternator put out alternating current?
No, direct current. Good question. Because there's diodes actually. An alternator actually produces AC, but through diodes, they actually only output DC because the battery only needs DC. You can't store AC. You store DC.
Well, can you tap into it before the diode?
No, well, you would start being in the world of the creative, and that would be leaving my world. I would not be part of that. But yes, I'm assuming it's possible. But where would you send it to? How would you regulate the voltage? I mean, yeah, you're on beyond my pay grade. Definitely beyond my pay grade. So inverters, you convert 12 to 120. So convenience items. They're portable or permanent. They're small. I mean, some of them are 100 watts, right, to 3,000, 4,000 watts. You can stack them. I have owners now that are putting 4,000 against a wall. They have 8,000 watt of inverters. Large battery banks, they're doing it, it sounds crazy, but what they're doing is they're using it as a way, they're doing completely inverter-based boating, meaning everything is in the battery, and then they recharge, and they're going to run their air conditioning. Everything is going to be run off the batteries. They're generally lithium battery banks, and then high inverters, and then everything, all the power from solar recharges the battery banks, and they'll never run an engine to recharge the batteries, right? So if you have inverters, there are ways to do that to run different things. Like I said, air conditioning, right? There are some people that run air conditioning off of inverters. Victron is a good example. You can stack them. I'd say the good size 2,000, it really depends what you want, right? Like I have, for example, on my boat, of course, 2 inverters. But there's a reason. There's an inverter that I use all the time that's always on. It's a 300 watt inverter. And that 300 watt inverter does multiple things. It runs all the computers on the boat. Anybody wants to plug in a laptop, it's always there, always on. I run Media Center from it. I have a TV in my boat, runs 40-inch LED TV. Runs that. Runs anything I want. All small little appliances run off of that. And I can leave it on all the time because it draws almost no power at idle. And then I have a large inverter, which is a 2,000 watt inverter, that I rarely use, and I only use and I only turn on when I need to. So it's a divide and conquer approach, because a large inverter, if you're not using it and you're leaving it on idle, actually draws power, especially the older ones. So it's good to maybe do a small inverter that you can leave on all the time, and then if you have guests, they can just plug in what they want and it's always there, versus a big inverter that you should not leave on all the time if you're not using it. Then in that big inverter, I will do, you know, like for example, we're crazy. I mean, I'll admit it. I have a espresso machine on my boat. So it runs off the big inverter. And I have the big inverter for the big charger. Yes, question, Julie.
I think this is the bit I never understood is if you're not actually charging something and it's not drawing, why is simply keeping it plugged in and turned on drawing anything?
Yeah.
What is it doing?
It's actually, that's the thing. It's a little bit, it's funny. I was in Mexico just recently visiting a client on a boat. And I was on shore, and believe it or not, they have microwaves there for shore that are 0 power consumption when they're not on. So when they go off, when you press the off button, they go off. Nothing is on. But when you turn them back on, the clock still, everything, there's 0 power. So they're meant for power grids where electricity people are more frugal and don't want to have things on all the time. On a boat, an inverter, when it's on but not producing power, it's actually still thinking. It's actually doing multiple things. It's got a mode that's called pass-through. Pass-through means it's seeing the AC coming in, and all your outlets are probably passing through the inverter, and the inverter is actually checking the AC, and if the AC wasn't good, it would actually close the AC. So it's actually a gatekeeper. It's also, if you have inverter on standby, but not on, like it's not working, it's going to be waiting for a load sense. Remember we talked about load sensing? It's going to be waiting for an appliance, and it's there just, by the way, and it's polling. I wonder if they're asking power constantly. And that draws 1 to 2 amps per hour. That doesn't sound like much, but 1 amp for 24 hours is 24 amp hours. A modern icebox conversion is about 30 amp hours. So now you have a device that provided 0 value other than being there when you need it and gave you almost the same power consumption as an icebox conversion.
So we've got the 3,000 watt Victron inverter charger, so I think that's 3,150 charge or
120 or something like that, 125. I think Victron doesn't have as big a charge rate, but yes, something around there.
Something like that.
Yeah.
And it's got inverter charge only. So if we're not physically using anything on 120, we should put it to charge only.
Correct. Absolutely.
Using it,
Yeah.
and then it wouldn't have any draw.
Correct.
Okay. And on the one, I can't remember what the charge is, 125 or.
Yeah, I think it's 125 on that one.
That sounds right. When are we really going to see that 125 charge?
On bulk charging, meaning when your batteries are at 50%. And how big is your battery bank?
1,000 amp hour.
Okay, so good size. Yeah, so you'll see it from anywhere below, and how old are the batteries?
2 years old.
So anywhere below, for sure 75% and below. And the moment that it stops being 125 amps, at that percentage point is when you stop being in bulk charge.
Okay.
So that would be, the moment that your charger reaches 14.4 or 14.6, probably 14.6, the moment it reaches 14.6 volts, that's when it's going to start tapering off.
It is a taper, it's not.
Yeah, it's a taper, but it's a pretty steep taper. It's actually pretty shocking.
So if we get back up to that 85%, are we
Then-
better off?
Yeah, you should stop.
Just shut the engine off?
Well, not the engine. You're talking about the genset, right?
Genset, yeah.
Yes, absolutely.
Yeah, 'cause
On a chart is a good point. I mean, okay, by the way, not many of us have a generator on board a boat, on a sailboat. Let's be honest. It's my dream. I'd love to have one. I don't. For the ones that do have a genset, it's a great thing. It's great. It's great. There's nothing wrong with having a genset on a boat. I mean, it's a great thing to have. You want to maximize the usage of it, and you only want to use your generator while bulk charging, right? Going from, on his boat, they're probably AGM your batteries?
Yeah, they're the light ones.
Yeah. So you can go from 30% to 80, 85% bulk charging. At 80 to 85, you're going to be starting penalized dramatically for a tax rate. You stop. It's better to charge twice a day, an hour a day, morning and night, than try to do everything in 2 hours, right? Stay in bulk. You'll need sometimes to get back to 100%, especially with AGM. You need to get back to 100, and if you don't, you will sulfate your batteries, and your batteries will not last as long as you thought they will.
And that's where the solar panel
Yes,
is going to
yes.
do its job.
Or eventually, if it takes you a while to go offshore, you go to Firefly. And that's the way to do it. Because Fireflies can live in a permanent state of discharge in perpetuity and never lose capacity. And that's why Firefly battery, we're selling 100 a month. And
Carbon fiber.
yeah, carbon foam. And that's the reason. I mean, they're the miracle battery. For anybody that's going to go offshore, seriously, if you're thinking of going offshore with your boat, your only real choice, in my opinion, is either lithium, which there are issues with, but there's validity there, huge initial cost, but validity for people that are actually going to use their boats, like 12 years or 12 months a year. The other alternative is Firefly. Firefly is unbelievable because it can live in a partial state of discharge forever and will never sulfate. You will never lose that top end that you didn't recharge. And if for whatever reason, when you get back to a marina after 4 months of not plugging in, you go back, you charge 100%, you're at 100%, and it's 100% of 100% of when you bought the battery. And you can have like I said, you can have 3,600 cycles at 50%. Your AGM right now is 450 at 50. So it's a factor of 8 times the battery life. And 450 sounds like a lot when you're cruising here, but when you're offshore, 450, if every day is a cycle, and maybe for you it's every other day, 450 every other day, that's only 3 years. And then you're in Papua New Guinea or something, and then you got to get lifeline AGM batteries, because that's what your boat's built for, right? So the question is, where are you going to be when you change your batteries? And that's why people are doing lithium. And when I was in Antigua a couple weeks ago, or a month ago now, it feels like, maybe less, a lot of people are doing lithium there. A lot of people are doing lithium.
So when you say you've got to go back to AGMs, when you switch to Fireflies, to the carbon foam, what difference do you have to?
Nothing.
You can just drop in
Yeah.
the carbon foam, right?
Yeah, it's so easy. That's why everyone's doing it. So charger inverter is similar to inverter. The advantage with a charger inverter, and it's really should be inverter charger, but we're just trying to emphasize the charger function, is that realistically an inverter or an inverter charger are almost the same price, pretty much. Most manufacturers don't even just do inverters anymore. And so they're doing inverter chargers like Magnum. Victron does just inverters, but Victron is an amazing company. They do great, they have a huge product line. So does Mastervolt, but most other companies are doing inverter chargers. And so you can have various sizes are available. Charges 100 amp, 2,000 watts, or 3,000 amps, 125, or Magnum does 2,800 watts at 150 amps, different ratios, but it's a good way to have a device that gives you a high charge rate and gives you nice inverting capacity.